Hello and welcome. This instructional video is a first step towards understanding the Garmin GNS 400W and 500W series units and the Waas system. The main focus of this instructional video is to help you understand the benefits of the Waas system and to describe some of the operational differences between the classic GNS 400-500 series units and the Waas-capable GNS 400W-500W series units. Let's get started. What is Waas? Waas stands for Wide Area Augmentation System. In the next few minutes, we would like to take the opportunity to provide you with additional information about Waas and what the Garmin GNS series units can do to enhance navigation within the National Airspace System. Waas is a very precise navigation system for aviation, which provides the additional accuracy, availability, continuity, and integrity necessary to enable pilots to rely on the global positioning system for all phases of flight. Pilots today can use GPS for many flight operations. However, to fully meet all navigation needs, GPS must be augmented to provide better availability of the signal and to provide usable vertical guidance. Waas provides this augmentation. Waas significantly improves safety by providing near-precision approach capability at almost all runway ends in the National Airspace System. Waas provides differential correction, integrity information, as well as vertical guidance on the approach phases of flight. This enables the system to provide a level of safety that has been unavailable until now. In July of 2003, the Wide Area Augmentation System was commissioned by the FAA over most of the continental United States, adjacent oceanic regions, and much of Alaska. Waas is one of the satellite-based augmentation systems certified for instrument flight. When Waas became available, aviation users were able to use Waas as a navigation aid for en route, LNAV, and VNAV approaches. There are over 1,000 LNAV VNAV approaches developed and published to allow pilots to safely descend to 350 feet above the runway threshold with the vertical guidance provided by Waas. In September of 2003, the first of the near precision approaches, known as LPV, became available, providing vertical guidance to a decision altitude of 250 feet. As of November 2006, there have been over 600 LPV procedures published. In 2003, the CNX-80, later renamed the GNS-480, became the first Waas-certified TSO C146A GPS aviation navigation system. In 2006, the Garmin GNS 400-500 series units received approval for the Waas upgrade. This upgrade certified new and existing units with upgrades to TSO C146A, renaming them GNS 400W and 500W. The Waas upgrade to TSO C146A gives the GNS 400W and 500W units LNAV VNAV and LPV approach capability. The G1000 integrated avionics system also received TSO C146A Waas certification in 2006. Let's talk about the structure of the Waas system. A network of 25 Waas ground stations located throughout the United States monitor GPS signals and relay data to two master ground stations. In turn, they assess signal validity, compute corrections, and create the Waas message. The message is then sent to a ground uplink station for relay to two geostationary satellites over the equator. The corrected differential message is then broadcast through two Waas satellites to Waas-enabled GPS receivers. There are two objectives to Waas. First, it provides differential corrections. Corrections to atmospheric effects on the GPS positioning signal are broadcast from the two geosynchronous Waas satellites, improving GPS position accuracy to less than 3 meters horizontally and vertically. Second, it provides integrity information and alarms. The Waas-certified GPS navigation system will alert the user of problems with the GPS system within 6 to 8 seconds of detection. Non-Waas units take up to 15 minutes before the user is notified of a problem with the GPS system. Let's quickly review the Waas structure. An aircraft equipped with a Waas GPS receiver collects GPS signals and acquires position. 25 ground stations collect GPS signal data. Collected data is sent to the two Waas master stations where the ionosphere correction values are calculated. The Waas messages and corrections are sent to a ground uplink station. Ionosphere correction values are transmitted to Waas satellites. Waas satellites broadcast correction values to be used by Waas-capable TSO C146A GPS receivers. Waas GPS receivers take ionosphere correction values to improve position accuracy. Waas coverage is only available in the United States. To receive Waas position corrections, there must be a ground station providing data from that particular area. Even though users can receive a Waas signal from outside of the United States, the signal only provides differential correction for locations in the United States. Other countries are developing their own satellite-based augmentation systems similar to Waas. In Asia, it's the Japanese Multifunctional Satellite Augmentation System, also known as MSAS. Europe has the Euro Geostationary Navigation Overlay Service, also known as EGNOS. With the non-Waas GPS receiver, typical positional accuracy is approximately 15 meters or about 50 feet. With the Waas GPS receiver, typical positional accuracy is less than 3 meters or approximately 10 feet or less. The Waas GPS receiver calculates its position 5 times per second, while the non-Waas GPS receiver calculates position once per second. This, together with the enhanced vertical accuracy and other system enhancements, allows for vertical approach guidance. With new technologies, integrity and capability of navigational equipment has increased significantly. Reception of ground-based navigation aids such as VOR and NDB are limited to line of sight as well as other interferences. With the introduction of GPS technology, the ability to navigate within the National Airspace System has increased. The addition of FDE, fault detection and exclusion, allows GPS to be used as the primary means of navigation in oceanic and remote airspace. With advanced Waas technology, you can now use GPS as the primary means of navigation through the entire route of flight from takeoff to landing. Let's discuss the approach capabilities of the TSO C146A GPS Waas unit. The approaches are categorized in 3 different levels. Gamma 1 or Class 1 category approaches are the traditional non-precision LNAV approach. Gamma 2 or Class 2 category approaches are the non-precision LNAV approaches with vertical guidance. Adding the advisory glide path to the current LNAV approach, LNAV plus V and LNAV VNAV approach. Gamma 3 or Class 3 category approaches are the GPS LPV approaches. The LPV, localizer precision with vertical guidance, provides ILS-like accuracy during GPS approach procedures. Here's an example of an instrument approach chart displaying a vertical profile to minimum descent altitude and decision altitude. Minimums are based on GPS navigation system performance. On this slide, every flag represents an airport that meets criteria that allows LPV approaches to be created. Information about LPV approaches at any airport can be obtained from the FAA website, www.faa.gov. Let's summarize the benefits of Waas in the National Airspace System. The GPS can be used as a primary means of navigation from takeoff to landing. Precision GPS approaches are available at a variety of airports. The GPS system can be used as a replacement for decommissioned ground-based navigational aids. The GPS reduces and simplifies equipment on board the aircraft.